are problems with Hot Maths 5C, experimental probability. Okay, I'm just going to look at questions where a lot of students have got a question wrong. Let's have a look at question 4. So in question 4, Sally tossed a coin 3 times and recorded the results. What is the probability that trial 4 will result in a tail? It's still 50%. It does not matter if you toss a coin 3 times and you get heads every single time. The coin still has a head and a tail. So the answer to this, the probability that you'll get a tail is 50%. Okay? Question 5 is fine. Question 6 I want to talk about. Hans drew a counter out of a bag, recorded its color, and then replaced it. He did this 20 times. So, from this data, what is the probability that the next counter will be red? We've got 7 red out of a total of, you have to add these all up, out of a total of 20, so it's 7 over 20. So the answer is 7 over 20. Okay, the next one that I want to go through is question 10. A box of matches is supposed to contain 30 matches. We've got number of matches up here versus number of boxes. This means that there were 18 boxes with 29 matches, 62 boxes with 30 matches. It says a box of matches is supposed to contain 30 matches. However, this number varies slightly between boxes. So there were 62 boxes with 30 matches, but there were 14 boxes with 31. This will happen naturally in production, right? The table shows a survey of 100 boxes. If one of the boxes were selected at random, what is the probability that it would have exactly 62 matches? How many boxes were there in total? You need to add these numbers down here to see how many boxes there were in total. So we need to add 18 plus 62 plus 14 plus 6. Well, 14 and 6 is 20. 18 and 62 is 80. Is that 100 boxes? So we've got 100 boxes. What is the probability that they would contain exactly 30? Isn't it 62? 62 out of 100, which is 62%. Because it's out of 100. Question 11. Holly's survey, just seeing how many people got this wrong, about 4. Okay, very similar. 5 students prefer science, 8 prefer maths, 7 prefer English. So you need a total, which is 20. What is the probability that the next student selects maths? Isn't maths how many out of how many? Maths is 8 out of 20. Now, to convert that to a percentage, you can times by 100%, or, and you would get, remember you've got a calculator, which is 40%, or you could just go 8 out of 20 to get it out of 100 times 5 times 5. 40 out of 100 is also 40%. Just explaining this again, you need to get the total. And to me it looks like there are 15 objects in total. Probability of bananas is just 5 out of 15, which is what? Yeah, bananas is 5 out of 15, which is a third. The first thing you should do is count how many sections there are in the counter. Anyone? 9 sections. And let's just see how many of each color. We've got 5 red, 2 blue, and 2 yellow. So an experiment was run to collect the results from this spinner. I know when you look at these different options here that they add up to all different quantities. But let's just look at the probability of red. Isn't it 5 out of 9? The probability of blue, isn't it 2/9? And the probability of yellow, isn't it 2/9 as well? So let's see which of these. So we really want more than double red than anything else. Do you see that if you're looking at that? So do you think the first answer could be correct? No. The second answer, really, blue and yellow should be similar. Blue and yellow here aren't very similar. Look, C has got blue and yellow quite similar. Red is pretty much double, almost double the yellow, almost double the blue. Girls, this is experimental probability. It'll never be exact. Experimental probability is not exact. It's just what happens in your experiment. Look, blue, this last one, I don't think the reds are high enough. Sorry. Yeah, the reds don't seem to be high enough for D. Do you see that blue and yellow are similar for C, and red is a bit, you know, it's more than double the blue, but it's not quite double the yellow. C to me looks like the best option there. Because, you know, we should have roughly equal numbers of blue and yellow and sort of a bit more than double of the red. But remember, it's experimental probability. It won't happen exactly like that. Experimental probability approaches theoretical probability the more times you spin. Okay, so for a very large number of spins, it would get very close to this result. But, you know, they've only spun it 20 times or 22 times. So the answer is C. Look, D is close, but the red isn't high enough. You'd be expecting the red to be about 40 something, to be more than double, like high 40s, close to 50, but it's not. Question 14, just having a look at that. We've got, again, experimental probability. We've got 4 different pictures on cards. Experimental probability is 0.32 and 1. Remember, the sum of all probabilities should add up to 1. And so all probabilities lie between 0 and 1. If you're doing an experiment, the sum of all the probabilities is 1, the sum of all the different options. Now, a pack contains those 4 types of cards. The table shows the results of an experiment where the card was drawn from a pack and replaced. What is the missing value in the table if it is found that dogs and birds are equally likely? What should I do, girls, if all probabilities add up to 1? I should, yes, add the horse and the cat, and we get 0.49. Is that right? And then 1 minus 0.49 is 0.51. That means dogs and birds should add up to 0.51. And divide that by 2. Remember, you have a calculator, and it's 0.255. 0.255. Okay? Okay, and that's your answer as a decimal. As a percentage, that would be, you would multiply by 100, and you get 25.5%, but they want the answer as a decimal. Question 15. There are 4 types of counters in a bag, each showing the numbers from 1 to 4. Can you see that there are none of number 3? There are none. No number 3s. The table shows the results of an experiment where the counter was withdrawn and then replaced and its number recorded. What is the theoretical probability that the counter will be a 4? So how do we do this? It's 4 out of... What do you need to do first? What do you need to do first? The total. What's the total? You add the columns. 4 plus 7 plus... Column 3 has a total of 0. And column 4 has a total of 5. That is 16. So the probability of a 4 is 5 out of 16. They want it as an exact answer as a decimal. Wait. And on your calculator, you get 0.3125. Exact means the decimal ends. Like 0.5 is an exact decimal. 0.75 is an exact decimal. 0.73 is exact. But if I had ... and my calculator continued with numbers, that wouldn't be exact. All right, so a terminating decimal, a decimal that cuts off at some point, is exact. Okay? Question 16. I think this is a maybe similar. Question 16. The table shows the results of an experiment where a counter was withdrawn from a bag, replaced and recorded. Now, what have we got? We've got 4 brown, 7 yellow, 5 red. What's the total of all that? 16 in total. Now, it says there are at least 16 counters in the bag. There are no blue. Now, which of these is true? There could be more than one correct answer. You need to read this very, very carefully. It's not like the counters are withdrawn and not put back. The counters are withdrawn and placed back. So we don't know that there is at least 16. Okay? because the counter is withdrawn and then replaced. So I wouldn't be putting A as an answer. There are no blue. We don't know that. There could be a blue. It's just that maybe there might be just one blue in there and we never picked it up yet. Okay? This experimental probability, you may not pick that one blue or whatever in there. There are 5 red. Well, we don't know that unless, because we could have picked up the same red one a couple of times. And there are at least 3 counters in the bag. Yes, because we know we've picked up a yellow, a brown, and a red. So the answer to that one is D. Okay, a survey of a group of people about their mother's nationality gave these probabilities. We've got Australian, English, and Chinese. Assuming the probabilities are exact, what is the smallest number of people in the survey? Remember, all probabilities have to add up to what? 1. Let's just see what we've got. 3/8 plus 1/6 plus 3/10. What do you think you should do anyway when you see all these fractions? Yeah, you want to make them, you want to make the same denominator. So what denominator could you choose?
No.
We need a number that 8, 6, and 10 all go into.
No, because then how?
You need a number that all of these, that 6, 8, and 10 all go into. What you do, you use the biggest number, start counting up by 10s. 10, 20, 6 and 8 don't go into that. 30, 6 goes into it, but 8 doesn't. 40, 8 goes into it, 6 doesn't. 50, no. 60, no. 70, no. 80. See if 6 goes into 80. Does 6 go into 80? 90, no. 100, 110, 120? 6 goes into 120. What about 8?
Yeah,
I think it does.
Yeah, it does.
120 is the denominator. So that would be 36 for the last fraction. So we've said that 120 is the denominator. So it's got to be, do you know how to make them all denominator 120? That one would be multiplied by 20. This one's multiplied by 15. 3 times 45. Okay, so these are our fractions. So Australian is 45 out of 120, English and Chinese. So, sorry, I should just have a one fraction, like separate fractions. Now, assuming that the probabilities are exact, what is the smallest number of people? What have we got? 120. So these are 3 separate fractions. The reason the smallest number of people is 120 is that's the smallest denominator that 6, 8, and 10 all go into. Okay, we can divide 120 by 8, we can divide 120 by 6, and we can divide 120 by 10. The way you do find the smallest denominator, you always look at the biggest denominator and you count up in multiples of that denominator until all the others, you know that they all divide into it. Okay, question 18. They've caught some fish and the color of the fish was recorded. Estimate the number of red fish if there are 40 fish in the pond. All right, girls, what's the probability of getting a red? Don't worry about the 40 fish question. Just look at the data. Red, isn't there 15 out of how many? You need to add up 22, 15, 37, and 46. Did anyone do that? So if you did choose some fish from a pond and these were the colors that you got, then your experimental probability of a red is 15 out of, I need you to add these up.
120.
15 out of 120. I believe that that simplifies to 1/8. If you do 15 ABC 120 on your calculator, you get 1/8. So if we think that the probability of a red fish is 1 out of every 8, if you sample 40 fish, if there are 40 fish in the pond, how many are red?
5.
So yeah, 1/8 are red. So therefore 40 divided by 8 is 5, or you could have gone 1/8 of 40 is 5. Here we go. It says the experimental probability of selecting one of 3 types of marbles from a bag are as follows. The probability of red is 3/5. The probability of green is 1/5. And the probability of blue is 1/5. Hello. If the green marbles are removed. So it doesn't mean that there are exactly 3 red, one green, one blue, but these are the probabilities. Now it says if the green marbles are removed, there's no more one green. So what is, won't there only be 4 marbles left? Like, well, the probability. So yes, so we've got 3 red supposedly and 1 blue. Like that's really the ratio of them. For every 3 red, there's 1 blue. So the probability of red will be 3 out of 4. And the probability of blue will be 1 out of 4. Because the green ones, we're not saying that there's only 4, but the ratios of the others. A ratio is like a fraction. They are the same. So we took out this 1. We're not saying there's exactly 1, but that got removed. So now we can consider that there is a total of 4. So probability of red is 3 out of 4. Probability of blue is 1 out of 4. Okay, just looking at question 19 here. A pack contains cards showing pictures of a horse, cat, a dog or a bird, and the table shows, this table up here shows the results of an experiment where a card was drawn from the pack and then replaced. And the question says, what are the missing values in the table for A and B here for the dog and the bird if it is found that a dog card is 3 times more likely to be drawn than a bird? So this is similar to a question we did earlier. We can see that a horse and a cat is 27% plus 31%. So the horse and the cat together so far add up to 58%. Now we know that the sum of all probabilities equals 1. However, we know that 100% also is 1. So if already 58% is taken up with horse and cat, we need to do 100% minus 58%. So we've got 42% left over between the dog and the bird. However, the dog and the bird are not equally likely. It says that it is found that a dog card is 3 times more likely to be drawn than a bird. So if a dog card is 3 times more likely than a bird card. So if we look at the parts, if we add up 3 and 1, we sort of get 4. So what we need to do, we need to divide this 42% by 4. So we go 42%, we divide that by 4, and we get 10.5%. So this 42% that's remaining gets divided up into dog and bird. Now, as we said, dog is 3 times as likely as bird. So we've really got to break it up into 4 parts. So the bird is going to be 10.5% and the dog is going to be 10.5% times 3, which is 31.5%. Now let's just check that. If we add 31.5 to 10.5, if we add those two together, we get the 42%. Okay, so just have to be careful here. You do not divide the 42 up into 3 parts. It has to be divided up into 4 parts because probability of dog is 3 times as much as bird as the probability of getting the bird. So your answers there for A and B are 31.5% and 10.5%.